In question 8, we've got a quadratic curve C here and a straight line curve L here. And we've been asked to describe the area R in terms of the inequalities generated by being above or below the curve C and the line L. So we first of all got to find the equation of the curve C and the equation of the line L. So let's deal with C first. So we're told that C is a quadratic. It's a U-shaped quadratic, and it has roots at 0 and 6. So I can say it does take this form. This will generate the two roots at x is equal to 0 and x is equal to 6. But the problem is there are loads of quadratics which will go through 0 and 6 depending on the vertical stretch we apply to the curve. So I must put a constant k in here to accommodate the fact that there could be a range of quadratics which go through 0 and 6. Happily, we know a point on C, the coordinates 1080, so we can substitute that into our equation and get the value of k. So 80, the y value, must be equal to k times the x value, which is 10, multiplied by 10 minus 6, which is 4. And if you do the maths, you find that k is equal to 2. So we have the equation of the quadratic, which is y is equal to 2x minus 6. Now the straight line. We know the intercept is 60, so we know that the form of the equation must be y is equal to mx plus 60. We're also given the same point on the line, 1080, so we can substitute those values in. And we get that 80 is equal to m multiplied by the 10 plus 60. And we get that m is also equal to 2. So let's start to consider region R, and region R is below the line L. So therefore y must be less than or equal to our equation for line L, putting in all the values, which is 2x plus 60. And also y, if we want region R, must be above the equation of curve C, which is 2x minus 6. And that's curve C. And those two inequalities will gain you your 5 marks and indeed enclose the area R.